my channel. So in the today's lecture we are going to discuss what is TCP Congestion Control. So in this video we are going to discuss what is congestion control. So in the data link layer, when we were studying data link layer, we discussed flow control. We discussed flow control in the data link layer. So firstly, let's discuss what is the difference between flow control and the congestion control. So what flow control says? Flow control means, let's suppose this is our sender and this is receiver. Okay, and each machine has some buffers. Okay, each and every device has some advertisement window size, or you can call it as a buffer. So this machine has some buffer. This receiver machine is having some buffer. Okay, so all the packets which sender is sending to receiver are going to be stored in the buffer like this. Okay, and all the packets which receiver is sending to sender are going to be stored firstly in the buffer of or in the window of sender like this. Okay, so all the packets which sender is sending to receiver, firstly it is going to be stored in the buffer like this. Okay, so what flow control says? Flow control says that buffer has some limited capacity. You can store the number of packets in a buffer in a limited manner. Okay, let's suppose the receiver buffer capacity is to store only 10 packets. It can store only 10 packets at a one particular point of time in its buffer. Okay, and sender is sending too much packets, like 20 to 30 packets. Sender is sending to receiver continuously one after another. But we have only space of storing 10 packets in the receiver buffer. So what we have to do? The remaining 10 to 20 packets we have to discard. Okay, we can store only 10 packets of the sender and the remaining 10 to 20 packets are going to be discarded. Okay, if sender send, let's suppose 20 packets to the receiver. So 10 packets we are going to keep in the buffer. The remaining 10 packets we have to discard. The sender is going to retransmit all the 10 discarded packets. We have to retransmit all those packets to the receiver. Okay, so that is basically a flow control. Flow control says there should be a proper coordination between the sender and the receiver machine. Sender should send packets only according to the buffer capacity of the receiver. Sender shouldn't send infinite number of packets to the receiver, because if you are sending more number of packets than the capacity of the receiver, you have to discard those packets and you have to later retransmit all those packets. So that is our flow control. And how congestion control is different from flow control? Congestion control is basically the capacity of the network. Okay, what congestion control means? Let's suppose we have a many number of networks. Okay, we have a many number of networks present. We have a many number of networks, and at a one particular point of time in the world, millions and billions of messages are put on the network, on the channels. Okay, at a one particular point of time, millions of billions of people communicate at the same time. So millions and billions of messages are going to be put on the channels. So our network is going to be very much congested. Our network is going to be very much jammed. Lots of messages are going to be present on the internet. So there is a chance that our network might get congested or it might get jammed. Okay. So that is our congestion control. Congestion control says we have to manage the total number of packets present on the network. We have to always keep on relaxing the network. We have to limit the total number of packets that are going to be present in the network. So if you want to relate it with real life example, let me give you one real life example. Let's suppose sometimes what happens, we get tensed. Okay, we get tensed and we start thinking too much. Okay, we start thinking too much and our brain become congested with thoughts. We get lots of thoughts and we get disturbed from our mind. Then what we try to do? We try to relax. We try to relax our mind. So same concept is here. You have to take care of this network. If you are sending too much packets on the network, it is definitely going to be congested. So congestion control says we have to manage the flow of packets in the network. We shouldn't send too much packets on the network. So that is our basically congestion control. So flow control is basically the coordination between the two machines, and the congestion control is managing the flow of packets in a one particular network. Okay, so that is our congestion control. Let me discuss this topic with one example. Okay, so let's suppose our advertisement window size is 32 KB. Okay, the advertisement window size is 32 KB and one maximum segment size is basically 1 KB. Okay, the one segment size is 1 KB and the advertisement window size is 32 KB. So how many total number of segments which receiver can receive is 32 by 1. The total number of segments which your receiver can receive is actually 32. The total number of segments which your receiver can receive is 32. Okay, so according to the receiver, we can transmit 32 number of segments. But it is not that we should be sending 32 segments at a time. Because we shouldn't only have to care the receiver, we also need to take care of the network. We have to take care of both the receiver machine as well as the network. So receiver says I can accept 32 packets at a time, but still we will not be sending 32 packets because we also have to take care of the intermediate network. Then what we will be doing? We will be dividing this 32. Okay, receiver capacity is to take 32 packets. What we will be doing? We will be dividing it by 2. Answer is 16. Okay, we are getting 16. So in this we have basically two phases. We don't send 32 all packets. We don't send the complete 32 packets to the receiver in the one go. We also have to take care of the intermediate network. So we gradually, try to increase the number of packets in the network. We have two phases. One is slow start avoidance. Okay, we have basically two phases. The first phase is slow start phase and the second phase is congestion avoidance. Receiver is saying that I can accept 32 packets, but by taking care of the intermediate network, we are just trying to gradually increase the total number of packets in the network. So these are the two phases in which we will be transmitting our packets, okay, in the network. So what we try to do in slow start phase? In slow start phase, we try to increase the number of packets exponentially. We increase the number of packets in the network exponentially. While in congestion avoidance, we try to increase the number of packets in the network linearly. Okay, in congestion avoidance phase, we try to increase the total number of packets in the network linearly, like one by one. We have third phase, congestion detection. How we will be detecting the congestion? When our packets are getting lost in the network, when we are not getting acknowledgement back. Because if there is your network is completely jammed or congested, so definitely your packets are going to be lost. And when your packets are lost, you will not get acknowledgement back. Okay, so how we will be detecting the congestion? First, timeout timer, and second one is three duplicate acknowledgement. So timeout timer means your congestion is really severe. It is very serious congestion. So timeout timer means your congestion is very severe, or you can call it as a very serious or critical congestion you are having. Okay. Three duplicate acknowledgement means congestion is not very critical. It is not very severe. Okay, not severe. So this 16, it is saying that the threshold value is a 16. Okay, this is actually our threshold value. The total number of segments which your receiver can receive is 32. So what I did, I divided by 2, I am getting 16. Okay, so what I have to do next? So we will try to gradually increase the total number of packets in the network. What we are doing, we are initially sending one packet. Okay, we are initially sending one packet 2 raised to power 0. Then when you get acknowledgement back for the first packet, then you will try to gradually increase the total number of packets in the network. Then you will be sending 2 raised to power 1. Or it is a slow start phase. You are sending the packets exponentially in the network. So next time we will send packets 2. Okay. And then next time when you get acknowledgement back for these 2 packets, we will be sending 2 raised to power 2 number of packets. We are sending 4 number of packets. Then we will be sending 8. Okay, we will be sending 8, 2 raised to power 3. And when you get acknowledgement back, you will again sending 2 raised to power 4. Or 60 number of packets in the network. So you reached at your threshold value. So I calculated this threshold value 16. So till threshold value, you will be in the slow start phase. This is our slow start phase till threshold. Next, when you reach at the threshold value, then you will be moving to the congestion avoidance phase. Okay, what we will be doing, we will be increasing the number of packets in a linear manner, like 17, then 18, then 19. This way we are going to send the total number of packets. Let's suppose next time 20. Okay, now you are sending 20 packets in the network and you are not getting acknowledgement back. You are not getting acknowledgement back. What do you interpret from it? There is a congestion. There is a congestion in the network. Let's suppose we are having a timeout timer. We got timeout timer here. So timeout timer means there is a severe congestion. The congestion is very critical. Then what you will be doing? You will be dividing it by 10. This is actually our new threshold. So now what we will be doing? We will again sending packets from the 1. So 1, then 2, then 4, then 8. Okay. In exponentially, we will again start from the slow start phase if you go timeout timer, because the congestion is very severe. So you will again send it from the slow start phase. Now after 8, you can't go to 16 because the maximum threshold value is 10. Okay, 2 raised to power 0, 1, 2, 3. So next 2 raised to power 4 is 16, but your threshold value is 10. So you will be moving like here, like this, 10. And after threshold value, you will again move linearly. Okay, like 11, 12, 13, 14, this way. This way we are moving. Okay, so when you get the timeout timer, you will firstly calculate the threshold value. Then again you will go to step 1. You will be moving from the slow start phase. Then you will be moving toward the congestion avoidance phase in case of timeout timer. But if you get, let's suppose you are not getting acknowledgement back after you send 14 packets. So now the congestion is what? The congestion is 3 duplicate acknowledgement. Now you are getting 3 duplicate acknowledgement when you send 14 packets. So the congestion is not very critical. So if you get 3 duplicate acknowledgement, then you will be moving directly from the step number 2. Then you will be moving toward the congestion avoidance. Because in this congestion is not very critical. You don't need to start from 1 like we did in timeout timer. The congestion is very mild. So what you will be doing? Just find the threshold value, new threshold value, 7. Okay, 14, 7. Then you move to step number 2, like 7, 8, 9, 10, 11. This way we will be keep on sending packets. If your congestion is very critical or very severe, then you have to go from the packet number 1. Okay, but if your congestion is not very severe, it is a mild congestion, then you can directly move toward the congestion avoidance phase. You just find the threshold value and just increase the number of packets by 1. Okay, that is our congestion avoidance phase. Okay, so I hope that you are clear with the congestion control. So this is my email ID creativeeducation2110@gmail.com. If you have any query, you can contact me on this email ID, and I have mentioned the same email ID in the description box. So thank you so much for watching my video. If you like my video, please like, share and subscribe my channel.